router and selected configure component option, and there I changed the configuration to machine. Is the correct way to do it, or if there is any other way?
I think that it is the correct way. I can share the screen and we can discuss then about the way how you did it.
Yeah.
So I will still repeat the basic steps here so that it will be clear for everyone. So when we go to virtual desktop, the first thing that you should do is to run the settings file, which is already here. I have saved it in my desktop. And after that, I'm going to open SolidWorks. And then PDM and drawings and every setting should be correct. And then I want to open my document from PDM. And last time I also told you that there is the filter, and at the moment it shows only assemblies here. And okay, now I see that something has happened. This is not owned by me at the moment. It's checked out by Kang Nguyen, which is...
Sorry, I made a mistake, so how can I fix it?
Okay, so you got my main assembly now at the moment, and it seems that it's not even here in this folder. Are you able to find this document?
What do you mean, like
Can you find this document, this S135772? Because when I click that one, it says that the document was not found. It kind of seems that it's not in this folder.
yes.
Is it somewhere in your folder?
But I can open it in your folder. I don't know why.
So, do you have your own folder at the moment?
Yes, I have.
So this is your folder which is visible now?
Yes.
So is this the same document? 773?
Yours is 772.
Oh, that's true.
I think if Khan goes to your folder, well, to Siemens folder, I mean, and then right-click this part and select check-in, maybe it can help, because this is how I used to do check-in.
Yes, that should help, but what confuses me is that I'm not able to see the file at all, because it says that this was not found, and that's the thing that I'm a little bit worried at the moment, but I can try. It says just that file not found.
Can I share my screen?
Yes, you
What
can.
is the solution? Can you see my screen?
Yes, yes, I can.
So I can open it without any problems, but I don't know why. Because in yesterday or some last few days, I just opened and see what have been done, and I tried to simulate it again in my folder, and by mistake I pressed check out. I'm so sorry about that.
No problem. So this is this 772. Okay, please do the check-in now. Yes. Okay. Now I will see if I'm able to open it. Yes, now it seems that I'm able to open. Thank you.
Yes, so I just closed.
But what a little bit still confuses me that why I was not able to even see the file. So that's something that was weird. But anyway. So now I'm opening the file again and I'm going to do this checkout, and this is exactly what I think Kang did. So if you just want to open something to see the file so that you won't get the ownership for the file, then you should not check this box, but you could only open the file. When this checkout is selected, it means that you get an ownership to a document. But now I want to get the ownership for the assembly, and also I want to get the ownership for this router and all the members of the router, to say so. And these ones I'm not able to check out because they are in a such stage that they are locked. I'm not able to select these at all. They are the standard components. Okay, but here it is. And the last thing that we did last week was that I added this sealing unit here. So the sealing unit consists of these sealing rings, and then there is this sleeve, which was meant to put first on a shaft, but I didn't do that on another side, so I think that this is the thing that I will do some repeating. I will add this part to another side as well. Okay, so now there is this sleeve, and then let's add this one also. Somehow I feel that this computer is quite slow today. Nothing happens even if I try. And the idea is to select just this corner. Which seems to be difficult now since the computer is so slow. But now it's there, maybe. And then this face, and say that they are coincident. Now it's in the initial position, and in real life you're able to tighten it by pressing this white part so that these ceilings will be pressed tighter against the sleeve. And still one thing I want to make sure that they are in the correct position. The bolt should be here. So I want to say that these are concentric. Okay, so now I have similar ceilings both sides. But there seems to be something special. Why it's not? Maybe it didn't take my original one of my mates, so okay, I will add one more so that it will be in a way I want. Yes, now it's there. And now what we miss here is the gear motor on this side and a bearing on the other side. And we could start with the gear motor here. So I need to open Moodle and see the instructions there. So there is this personal assignment. And here you see the gear motor. And I think there should be some information. Rotor rotating speed 60 RPM and needed power 1.5 kilowatts. So these are the basic information that we want. And also we want to have such a gear motor that we are able to connect with the flange, and so that the shaft of our rotor goes into gear motor. So we have a hollow shaft here in a gear motor. These are the main specifications that we would like to have. I thought that there would be a link. I remember that I had put a link for this SEW page, but was it here? Okay, it's over there. I need to make it visible for you. So let's have a look at this gear motor catalog. So this is the main page, and you see different products of this certain company. There are, of course, many other companies as well that are producing this kind of gear motors, but now I wanted to use this SEW as an example because they have quite nice information, and a lot of data will be found from internet. So there are gear motors, gears, explosion-proof designs, and some other stuff here. But now I'm interested about the basic gear motors. So I will select the first link here, AC gear motors. And this is a configurator page. The first selection here is the gear unit design. And you see here a picture, how it looks like. And at the moment there is this letter R, which means helical gear unit. But if I compare this picture to the picture here, I can see that this is not a correct type. I don't want to have this kind of gear motor. Instead, I want something else. And if I select another letter, you will see that the picture will be changed. This is a helical worm gear unit, which is not the one we want. Then W, still not looking the same. Then parallel shaft helical gear unit. Okay, this looks more the same, but still we have a shaft coming out of the gear motor instead of a hollow shaft, so that we could put the rotor inside the gear motor. But maybe we can modify this one. But we can see the other options also. H. No, definitely not this one. K. Not this one either. So this F is the one that we want to use now. Then there is a country of use, and why this is asked, it's because of electricity. Different countries have different electricity network, and they operate with different voltages and different frequencies. But we can use this 50 Hertz now, since we operate in Europe. Then we can put here that what is our motor power. Well, it was 1.5, so by accident there is already a correct number here. Then the output speed, this is not the correct number, but we wanted to have it 60. Then the service factor means that kind of how much we have now I forget the English word for varmuuskerroin. Do we have any Finnish people online? Seems not. But how much we have why this is so difficult in Monday morning? And way to overload the system, to say so. The bigger the number is, then we would be able to overload it more in a point of view taken from the gearbox. This is not meaning the electric motor, but how much we can put overload on gearbox. So you should select a little bit more than one here. But there will be a list here of different options, and you can see the service factors over there. So we can later select suitable one. We don't need to change anything in here at the moment. Then this is an efficiency, that how efficient is the motor, number of poles, and some duration factor, meaning that how much in a day we will operate with the motor. Well, that kind of information was not told in this original question, so we can keep it in this default setting, so that it will be operated more or less all the time. And after we have set all the values here, we have list of different options here. So if we will change something also, oh, this was too much. Also, the list is changing here. But 60 was our target. And I see that, for example, the first one here, the output speed is not 60 that I wanted, but it is 71. So maybe I will select the next one. Then in here, the output speed is 57. It is already quite close to 60, which was our target. And I see also that what is the output torque from the shaft, what is our gear ratio, and the service factor. And this one is the output speed of the motor, but there is really not so much difference that what is the output speed of the motor. More I'm interested that what is the output speed of the gear. So since this is a combination of the motor and gear, well, they provide information, the output speed of both of them, but the output speed of the gear is the one that matters. So I would say now that this is more close to our target than the first one. And if we look at the other options, what are available, 51, 76, 50, 67, 86, 52, 49. Well, I think if the output speed is the most important factor, then the second row is our option. Also, I see that the service factor is big enough, so it's good. And what we can see here from the code it says FA37 and this one starts FA47. So this FA is the model of the gear and the number is the size of the frame. So this FA37 has a smaller frame compared to this 47. And then I see here that we have already FA57, so it's even bigger. But as a conclusion, I think this is the most suitable one for us. Then in next page, I'm able to give some other specifications. The mounting position. You see here what it means. The default position is called M1. It means that it is installed in this kind of position. What do you mean, Danila? You wrote that you can go to the second page to see other options. I just noticed that you wrote something on the chat, but I don't fully understand now what you mean. Okay, I go back here, inserts. You mean here, and you mean this other page is here in bottom. Yes, it's true. It's true that there are big list of different options, but I think that I was still quite satisfied with the one that I had. I see that there is something, this is even close to the 60, but it is an FA57 which is bigger, way too big. The service factor is already 2.4. It is more heavy, more expensive. It doesn't make sense. So I will I will still stick to this one. Okay. So why it's important to specify that what is the mounting position? Well, if you have just a motor, it's not so important, but since there is a gear and there is oil inside the gear, so the manufacturer needs to know that what is the position that you want to run the gear motor so that they can put correct amount of oil and they can put oil metering holes in a correct place. Because if the oil if there is a wrong amount of oil in different position, then it might cause a failure. And this is actually very important since they are normally operated in a long time continuously. But we can now use this M1, which was the default. The pivoting angle means that if our mounting position is not exactly one of the options, we can say that it is M1, but it is toward some other position with certain angle. Well, now this is important in our case. So I thought that we want to have this hollow shaft. And at the moment, this FA stands for hollow shaft. If we just select F, you see that now there is a shaft coming out, which is not what we want, but instead we want to have this hollow shaft. But in addition to the hollow shaft, I want to have such a gear motor that has some connection points here. Now I don't see any. I want to have a flange connection. I want to have a such flange connection that I'm able to attach the gear motor with this kind of holes here to this flange. So let's see what are the options. Well, this one says flange mounted design. Well, we have a flange mounted design, but we have also a shaft coming out, which I don't want to have. So FAF is a flange mounted design with hollow shaft. This seems to be very good. Actually, this is the one that most likely we are going to select, but let's see the other options also. This is with hollow shaft and shrink disc, so there are different options to transmit torque. This one is using the shrink disc. This FAF is using the key. This one is used a splined hollow shaft. Well, we want to have this key connection, so I think this FAF is our best option, or then this FHZ, which is actually otherwise the same, but the flange has different holes here or different connection points. It says that the flange here is 80 millimeters, but we are not able to change it anyway. And in this FAF, the flange, the overall diameter is 200 millimeters. And now in this point, we can go to check from our SolidWorks file that what is actually our diameter here. It is 220. So it means that I think that we could live with this flange that diameter is, outer diameter is 200. It could fit quite nicely on here. So the selection is this FAF. Then there are still some other options. Position of terminal box. It really doesn't matter so much in our case. And the cable entry position. So we can specify this quite an accurate way if we want. Well, I'm satisfied with these values, and I will go to the next page. And now here you see the list that you can still specify it. This is not so, in a mechanical point of view, any more so important things, but in other point of view, there might be very important things. For example, that what is the quality of oil, what kind of corrosion protection there is, what is the color, is there a brake, other things what you see here in the list. in here, the top one, you can specify what is the color. Let's select lemon yellow. what kind of corrosion protection there is, standard or something else. Then a voltage, but let's stick it here so that this is a standard and default connection. Then you could attach a brake, some safety brake, but we don't want to have that. What kind of thermal protection there is, or thermal class. Then an IP classification. IP55 is good. Do we have some kind of temperature sensor protection in that way? What kind of connector we have? Do we have any speed sensor? What kind of fan we have? And many other things. These were all options related to the motor, and then here we have options related to the gear. And in gear options we are able to specify, for example, if we would like to use a stainless steel shaft or some inch dimensions instead of millimeter dimensions. And what is the lubricant we want to use. There are different viscosities in these lubricants so that they will operate in different temperatures. What kind of sealings there are. And the spreader valve, standard or made of stainless steel. These kind of things. Well, at the moment I'm satisfied with this very basic information, but as you can see, you can specify it in a very, like I said, very accurate way. Only change that I did was that I changed the color to lemon yellow. Then there is a technical data once again, a product preview here, and when you press this button complete, it will generate, at least it should generate a CAD model. So you would be able now order this product, but I think that you don't want to do that one. But instead, there is this button, Retrieve CAD Data. So let's try if it works. It is now in step format. I think this is by default in a step format. You are able to select some native AutoCAD format, for instance, or it has been in SolidWorks format also. But I think that this step is the best option what we can use with SolidWorks. Normally, if you have an option that you could use a native SolidWorks format, I have very bad experiences about them, and I recommend that instead of this native SolidWorks format, you should use this step. Because in SolidWorks there are these different versions, and usually this kind of third parties, they are not. It might be that they are not using the same version what we are using, and then it causes problems. But the step usually works fine. And now I'm able to download the step file. there. And let's open it. I think some drag and drop would work also, but now I want to open it from downloads. Do you wish to run import diagnostics on this part? No, at the moment I don't want to do that. So here it is. The motor that I specified. And since we are going to save this in a PDM again, I need to give some information for this motor as well with CustomWorks. And now if we would use these kind of item types, this would not be manufactured, but this would be purchased if we would like to classify it this way. And in some companies, they use different item numbers for self-manufactured parts and purchased parts, but we don't have such a difference, so I will just press this Get New. And this is a motor, and in dimensions I will put this type, which is FAF 47TRN 90L4. And then I will save this in the same folder that I have saved everything else inside PDM.
So we didn't use any preform, right? Just the description and item number and description.
Yeah. I think this preform is not applicable in this point because we don't need to give any raw material for it. It's a purchased component, so the important thing is to give the code what you could use to buy it. If we would like to be more precise, actually, it would be important to give this output speed and power options as well. So I little bit gave too little information.
Should we check it in? Or
You can do it. You can do it now or then later. Okay, here it is. And let's see how it fits. I want to make this surface and the shaft. And then I want to make this surface on this surface. And then are the holes in the correct position? Maybe they are. I see a hole here. So let's try whether it works. Yes, it seems that these flange connecting holes were having a perfect fit. So this part, which is now visible in blue, was designed so that it can be used with this special gear motor. But as I can see, the shaft is not suitable. It is too long, and I think it is also having the wrong diameter. So it's definitely wrong dimensions with our shaft at the moment. It's way too big for this gear motor. But the gear motor flange fits perfectly to this end plate here. Also, you see that this connection, they have the same, exactly the same diameters. This has radius 65, and if I'm able to select this one, oh no. Too difficult to select that, but anyway, they have the same diameters, and the holes are in the correct places. Okay, but then how do we know that what dimensions we should give to shaft? Well, we can go back here, and now the place where I downloaded the 3D file, there is also some other information. There is a place called documentation. But even though if I don't go to the documentation, I will see that output shaft has 35 millimeter diameter. And in our case, the diameter here, how much it is 50. So I can immediately say that this one should be 35 instead of 50. And now I can also see that this length of the shaft is still not correct. So I will do some small modifications. I will change this length. Maybe it was not that length, but I need to change this length to be more than 150 so that it will go like this so that we are able to see here. So now the main diameter would be fine, but still the overall length of the shaft is too big. So let's find the correct documentation so that we are able to see what kind of dimensions we should have. So under documentation, we can open operating instructions, catalogs, and so on. and wiring diagrams. And as you can see, there are different language options, even in Finnish, but also some German, Russian, Spanish, Swedish, Chinese, and so on. But now I think it is the catalog that we need, but I don't remember which one is the correct, so that we are able to find those dimensions. I can try this gear motor. Okay, we have more than 600 pages, so it makes no sense to go through all of them, but let's have a look here. Mounting positions. Okay, there are this information, design and operating notes. I think this is not the correct document at the moment, but I know that we still need these documents also, because there is some information given that what kind of shaft we should have. Well, maybe actually we can get the information from here. Installation and removal of gear units with hollow shafts and keys. Customer shaft with contact shoulder and without contact shoulder. Well, we have a contact shoulder. And actually there is the information what we would like to have. But there are still two options. This case, and in next page I believe we have another option here. And the difference between this one and the previous one is that there is this one extra part which helps to remove this shaft out of the gear motor, this removal part, or how do they call it? Retaining ring. No, it's not retaining ring, but this part. They have this so-called installation and removal kit. You can also use the optional installation and removal kit for installation. And if you want to use certain kit, then the shaft has little bit different length. But okay, we should not use that one. Let's keep it more simple and let's have this case so that we don't have this special removal tool. So from this table we can find our gear unit type. It was FAF47. So there we have FA, but it is only 27. Over there is FA37, KA37, SA47. No, not our case. But in here we have this FA47. Well, we see that D, which is the diameter of the shaft, and the hole is 35. That's something that we already knew. And the length of the shaft should be 132 millimeters. So it's this L8. The dimension from the contact shoulder to that point should be 132.
Sim, I somehow struggle to change the length of this shaft until the contact shoulder. I don't know, like it's demolish all the extruded cut that I have. I can share my screen probably.
Yes. Okay. Let's do so. I will stop sharing my screen.
Mm. Do you see the screen?
Yes.
Okay. Right. So I added the motor, but then it's all ruined. Was ruined, and I took it away. So basically, I want to change this length, right?
Yes.
From 152 to 132 now, right?
Yes. Exactly. That is the information that we got.
Yeah, and like my chamfer is disappeared. And if you check the side view, it's now. Oh.
Okay, that's interesting.
So I can't even return it back. So I need to.
Really?
Oh
So
yes.
Control Z is not working.
No. And then I came back to the previous version.
Are you able to change the diameter?
Yes, as far as I remember. So it needs to be 35, right?
Yeah.
Oh no.
Do you have ownership to all these parts in a rotor at the moment?
Yeah, I checked that out. Everything.
Okay.
Even whatever it is.
What if you open the
Open what?
open the rotor? Since now you are working in main assembly, what if you open the rotor and try to do those changes now here? Because I think they are made originally in this assembly, right?
Yeah, maybe. No, it's the same problem, as you can see. So it's all done.
Show me your configurations.
Wait a second. I need to back it up again. This is kind of clumsy way to do it. So my configurations are here.
Okay. And then if you show me the features, what you have there.
So
different cut extrude.
yeah, I think they are same as you did during the
Yes.
last lecture.
And it was this cut extrude 8 that you changed.
Yeah, so maybe I need just to change the feature, but it's quite strange because it works for you and it doesn't work for me. So it's not 50, it's 35. Or is it? No, it's in depth. Yeah, it's the wrong dimension after all. I think I need to edit sketch for this. It's broken again.
No, don't close it yet. What if you press this Control Q so that you try to update the view?
I'm not sure there's a good way to do it because in my original keyboard, Command Q is for closing the window, so I might just ruin the whole assembly. Unfortunately, so let's save. Come back again.
Somehow it feels that there is something wrong in your file. This is not a behavior how it should work. But is it doing it? Okay, now it works.
Yeah, because I edited the sketch, not like the whole lens. But now I also need to put this to 200, I guess.
Or
I can break
put
it
it
again.
is 132, that is the information.
Oh yeah. Okay. But I'm a little bit confused because these dimensions are blue and they are undefined. But it's quite strange because when I used when I created this assembly originally, it was all right and it was black and showed the correct length. Maybe I should click all the other features here.
But are you now able to change it to 132?
I'm afraid I'm gonna fail. Yeah, no luck. I need
But now, do you see it?
Oh,
Yes.
I rebuilt it. I guess it worked now.
Yes, it needed to do some rebuild. You saw these traffic lights there.
Yeah. So it's done then?
Yeah, I think so far.
So I need to save it and then open the large assembly. Yeah, now it's changed. Now I can attach the motor. Okay, thank you.
No problem. Okay. So back here. So we figured out that the correct diameter is 35 and the correct length here, instead of this 200, should be this 132 based on the information that was given. But I see that if I do it in that way, the shaft in general is way too big, so I need to modify the main dimension that I gave to the shaft in the very beginning. If you remember, I said that this distance is 250, then from to the other side it's 200, and then to this gear motor side it's 350, and now I see that this dimension is too much. And how do I know that what it should be? Well, I can make a measurement, evaluate, measure, and I see that now at the moment the endpoint is here. I try to select it. From this phase to, I think this is the point here where we should go. 48 millimeters. It's 48 millimeters too much. So $350 minus 48. And now it's there. It's starting in a correct point, and it is ending more or less in the same place where the gear motor is ended here. But I see that this diameter is too big at the moment, so I think we need to have one more let's say removal of the material so that these are not touching each other. So I need to add one feature to the rotor. So now this 132, and and this 35 diameter, they are the correct information and I don't want to change them. But I need to add one more assembly feature, extruded cut, and I want to remove material from this place. Let's give, for example, 40. And something like 100 millimeters long distance. Maybe that was too much, but we will see. Then go back here. Yes. Looking good, but this 100 was too much. So let's change it to 60. Yeah, now it's looking pretty nice. Maybe this diameter could be even a little bit more. It seems that there is still space left, so instead of this 40, we could use 45, I think, at least. It's still okay, maybe this is better. Now, if we have a look at the total construction, if we would do some calculation for the shaft, I'm pretty sure that we would be able to make it much smaller here in the middle and make all the diameters to be smaller. So this is way too oversized at the moment, but I think this is something that we are not going to do now. We don't have so much time to do that. That's not our main target in this task. Just want to say that starting from this main diameter here, all the steps could be a bit smaller so that we would not need this one removal at all. But then it would mean that we would have to have different size ceilings as well. And this is the only ceiling that we have at the moment available here in a 3D model. So let's not change anything. But at the moment, the length of the shaft here is correct for this gear motor. But still in this gear motor, there is a key. And we don't have any keyway in our rotor. So if we have a look, if I open this file, we see here that there is a keyway, and there will be a key between a shaft and between the gear motor and the torque. The power is transmitted via this key, and of course we can do some rough measurement here. We can see that the width of the key is 10 millimeter, but we also know that those keyways are based on the standard. And now if we go back to Moodle, there was this one place keyway standard, principle of keyway, which are at the moment hidden. Let's make them visible also. Oh, come on. So the basic principle of keyway just telling that the key is something which is between two elements, two rotating elements. And there is a standard looking like this. There is a shaft, a hub, and the key between them, and the B here is the width of the key. And the nominal diameter of the shaft is 35, so it's here between 30 and 38. And the nominal dimension, the nominal width here is 10, like we just measured. But now, since we are interested that what kind of keyway we should create to the shaft, I want to see that what should be the depth of the keyway on a shaft. And according to this information, it should be 5 millimeters. So we have to create a keyway. And now, what is the best way to do it? We want to have a keyway in here. If we would start it from this direction, then the end of the keyway would not be round as we want it to be. So it makes more sense to create a keyway from this point of view so that we are able to do it in here. But we need to create one reference plane here, which we will use as the starting point to a keyway. So I need to start with reference geometry, a plane, and I wanted to put it on here. And then I want to give a second reference, which is our, for example, top plane. So now I have an additional plane here, plane 1. And when the plane 1 is selected, I will create an assembly feature, extruded cut. And then I'm able to make the shape here. And then I want to make sure that it is in the middle. So I will select the midpoint from here. And then press Ctrl and Okay, I'm not able to select midpoint from here. Maybe I will first select the, at least try to select the midpoint. Should be visible somehow. Okay. Okay, now it's there. Why it's not possible to select? Right, let's do it. So this is maybe not the smartest possible solution, but I will create a central line which starts from the midpoint. And then I will say that midpoint of this line coincident. Come on. Finally done. And then the width, which should be this 5 millimeter according to standard. And then how do we know that how long it has to be?
Sima, is width 5 centimeters or 5 millimeters, or is it depth 5 millimeters?
Oh, yes.
I think with
Depth should be 5. This is,
yeah.
Yes, you are absolutely right. That was my mistake. So this should be 10 instead of 5. Okay, but this dimension, how do we know that how much it should be? We can go here, or actually go to this page, and actually you see the keyway here, and it tells that the keyway length is X, and then the distance from the contact shoulder should be 0.5 multiplied by the diameter of the shaft, so it should be 0.5 multiplied by 35, which is 17.5 millimeter. So the end point should be 17.5 millimeter to the contact shoulder. What else we can see from the picture if we have a close look? We see here that it tells us some tolerance values. It tells that the shaft tolerance should be H6 where is the key and G6 in a place where is no key. But I make it in a little bit different way. It won't make sense to have, for example, two different tolerance values in this part. And also in an assembly point of view, it is smarter to have a keyway, and in a manufacturing point of view, it's smarter to have a keyway which goes through the end of the shaft. So I'm not going to use this kind of key here, which is only certain millimeters long, but I want to use the key which or at least the keyway, which goes here at the end of the shaft. But this distance between this point and this point should be this 17.5.
Shouldn't it be 22.5? Because we take into account the radius, or...
Yes, but I'm going to change this
okay.
to be given in different way. Like this. So now it's given according to the information, or now the dimensions are in according to the dimension given in this catalog.
Could you please show again how did you select the endpoints with the dimension menu?
This one.
Yes.
Yes. Just a moment. I will first finish this one. So the depth was now this 5 millimeter. Okay, so back here and edit sketch. So first you need to put the dimension between this and this, and don't worry if it points to the center. But when it's selected, if you go here to the other seed, which is called leaders, you see here arc condition, and you are able to select between center, minimum, and maximum. Did you find the place?
I don't have this. Well, I have the leaders option, but I don't have the min-max arc.
Then it might be the situation that when you created this dimension, you didn't select this rounded shape, but you selected something else. It works only with circles and or radiuses. So if you start again, so that delete this dimension, and when you create a new dimension, make sure that you select this part, not, for example, end of the line. But you can.
How about the? Yeah. What if I selected the midpoints?
Then it don't work.
Oh, that's the problem then. Okay, thank you.
All right. Then if we have a look at this picture still a little bit, we see that there is a bolt. Retaining screw with washer. So we have to make a hole with threads into our shaft so that this kind of bolt you're able to put there. I'm just wondering whether it's set somewhere. Well, I remember that the size of the bolt is M16, but I don't know if it's set somewhere. or I'm sure that it is told somewhere, but I would need to find the correct place from the book. So since we don't have so much time left, let's just agree that now we need to create a hole that has M16 threads based on the information what is given in this book, but maybe I can later find out the correct place where it was told. Or is it here?
Isn't it in the table, like under M?
Yeah. It seems that it is over here. Yes, it tells M and then FA. Okay, it's not M16, but it is M12. Yes. Okay, so let's create a hole which is M12. The bigger ones have this M16. So in this assembly of the rotor, we still need to create one more assembly feature, the hole wizard. Standard ISO, and we want to create an tapped hole, the size with M12. And how deep it should be, well, we can estimate it, or was there any information given for that one? Not directly in this table. So let's just estimate. Okay, we can see that the length of the bolt L4 is 45 millimeters, so it makes sense that we have at least 50 millimeters threads there. And condition blind, and we want to have 50 millimeter thread, and then a position where it's going to be. I want to have a midpoint, please. Okay, what happened now? A new trial. Wizard M12 tap thread 50, position on this surface and in the middle, and that's it. What? Please select the vertex to complete the specification. Now I don't understand what it is saying to me.
Could it be that you selected up to vertex instead of a blind option?
Okay, let's try to sketch a new dot. I don't understand what is the problem, but something strange is happening. Is it somehow that this was not fine? It won't let me. Won't let me put it in the middle. Have you managed to do this?
Yes.
What if I'm not going to put it in the middle, but somewhere else? No. Feature scope all components. Is it this thing?
You have up to vertex selected. I think it might be the problem because it should be blind, and it was asking for a vertex.
Yeah. Sorry. You already told me the problem originally, but I didn't believe you. Okay. Now it's there. And everything what we did here was done in this machining configuration. So if I go back and activate the welding, it is just the plain shaft without any shapes. But when I activate the machining, then we have all the holes and keyways and such information there. But somehow I think that I misestimated the needed length for the hole if this 3D model of the gear motor is correct. It seems that we have way too long hole, but it can be as it is now. So we managed to put a gear motor, select a gear motor and put it in a correct place and modify the shaft so that it fits the gear motor. And but today we didn't have time to put a bearing on another side. And also we need to do some finishing for the shaft. We need to add some chamfers, for instance, but we can do that still on next week and modify it, and then what is left is this 2D manufacturing drawings. But did you have now any questions? Did you manage to follow the things so far?
Yeah, I think everything up to date.
Me too.
Okay, good. Yeah, so if you faced some problems, you can send me email, but the plan is that you should have the same stage for next week. Then we can do the final steps. And of course, if you have time, if you want to do it alone, you can study the information that I activated already. It was this engineering data for the bearings, and we are going to attach an flange bearing unit in here, and we need to modify this part a bit, and we need to modify a shaft a bit, and then find the correct data from the catalog. So if you want to be proactive, you can study and try these things alone. But otherwise, we are almost finished. The thing that we have to do still is to save everything and go to PDM. And as I can see now, there is several these green symbols that tells me that there is some update in my parts and in my models that needs to be changed. It's the main assembly, then it is the rotor, and it is the shaft. These three documents have been changed, and I need to check them in. Okay, now I press cancel. I want to check everything in the same time, so I select the main assembly and then button check in. And I want to check all other documents that didn't change. Also, at the same time, all the documents which are checked out for me, I want to do the check-in, and I don't want to keep them checked out. So there is this gear motor, which is a new component, and then the rotor, and then the main assembly. Check-in. Yes. And now we are finished for today.
Thank you.
Thank you. Bye.
Thank you. Bye.
Goodbye.
Thank you. Goodbye.